Welcome viewers, lovers of mathematics. I am tutor Cletus College. In today's maths, we shall be taking logarithmic equations. It is given to us and written on the board is if log of 2 raised to the power x plus 48 is equal to x minus 1, then what should be the value of x? We solve direct. Solution to the question. I am given to solve the logarithm of 2 to the power of x plus 48 are equal to x minus 1 to base 4. Okay, beautiful. The question is to the base 4, and we're looking at this by definition of logarithms. It is defined that the logarithm of a number to base a. If a number, log of a number to base a is given, the definition says that a to the power of x is equal to n, implying that the logarithm of a number n to base a is the power to which the base must be raised in order to obtain the number. In other words, that the log of 2 to the power of x plus 48 equal to x minus 1. Therefore, 4 raised to the power x minus 1 should be equal to 2 raised to the power x plus 48. Applying this definition of logarithm, I will now have 4 to the power of x minus 1 is equal to 2 raised to the power x plus 48. This is by definition of logarithms, and it is 100% correct. Now, I can now apply the power of indices. Alright? 4 is the same thing as 2 raised to the power 2, and that means I can represent 4 as 2 to the power of 2, or to the power of x minus 1 equal to 2 to the power of x plus 48. But by law of indices, I can also multiply 2 into the bracket to get 2 raised to the power 2x minus 2 is equal to 2 raised to the power x plus 48. Beautiful. Still on the law of indices. If I have 2 raised to the power 2x minus 2, it can also be written in indices as 2 raised to the power 2x, then multiply by 2 raised to the power minus 2 equal to 2 raised to the power x plus 48. By law of indices, this is very correct. That is, if I have x raised to the power a multiplied by x raised to the power y, it is or even minus y. It is the same thing as x raised to the power a, then minus y. Okay? This is very correct. Beautiful. Now, going by where we are, if I have 2 to the power of minus 2, it is the same thing as 1 all over 2 raised to the power 2. By law of indices called negative power index law. Now, moving forward, I will now have it written 2 raised to the power 2x, then multiply by 1 all over 4, because 2 raised to the power minus 2 is 1 all over 4. Is equal to 2 raised to the power x, then plus 48. This implies that I can multiply, or let me move everything from the right hand side to the left hand side to get 2 raised to the power 2x, then multiply by 1 all over x, minus 2 raised to the power x minus 48 is equal to 0. At this point, I can multiply everything in the equation by 1 over 4. The reason is because I want to get rid of this 1 over 4 here. And doing that, I will have the expression written as 2 raised to the power 2x. Okay, having multiplied this place by 1 over 4 it will cancel out this one out. Sorry, multiplying both sides by 4, or the expressions by 4. So this place can now disappear. And then leaving me with the 4 minus 4 into 2 raised to power x, then minus 4 multiplied by 48 equal to 0. What have I done? You know that 1 over 4 multiplied by 4 is equal to 1. So I have multiplied all through by 4. And it resulted to this expression we can see. But then, this is the sentence as 2 to the power of 2x, then minus 4 into 2 raised to power x, minus 4 multiplied by 48 should give us 192, which is equal to 0. At this point, let, y be equal to 2 raised to power x. That means by law of indices, 2 raised to power 2x can now be written as 2 raised to power 2x can be written as 2 raised to power x, then all to the power of 2. And when x, 2 raised to power x, is assigned to the y, I can now have it here written as y raised to power 2, then minus 4, multiplied by y, because y is assigned to be 2 raised to power x, so that becomes 4y, alright? Minus 192 is equal to 0. Very good. From what we have now, I have resolved the equation into a quadratic equation. Therefore, I can use any of the methods of quadratic equation to solve this, to get the value of y, and thereafter, I substitute y to get the value of x. Alright, let me go by factorization method, and that means y raised to power 2, minus, 16 multiplied by 12 will give me 192, alright? Since 192 is negative, and the 4 is negative, I can make this 16 negative as well, so that minus 16 times 12 will give me minus 192. And that means I can now substitute minus 4y to become minus 16y plus 15y. Minus 192, everything is equal to 0. Moving forward, I can now factorize what is common from the left-hand side of the equation. And that means y is common, giving me y into y minus 16. In the second bracket, I have plus 12, leaving me with y minus 16 as well, equal to 0. Alright, as we move forward, this will now be, for me, what is common here, I have the brackets the same, so I form a bracket again with y outside the bracket here and the plus 12 to get y plus 12, then into y minus 16. Everything now is equal to 0. This implies that the first bracket, y plus 12, is equal to 0, implying that the value of y should be negative 12. And for the second bracket, also, y minus 16 is equal to 0, meaning that y is equal to positive 16. Remember, I am asked to find the value of x, what x should be. This is the logarithm to base 4, not x to the power 4. Beautiful. Now, you see, I am looking for x, not for y. But here I said let y be equal to this. Therefore, remember that y is equal to 2 raised to power x. Therefore, when y is equal to negative 12, it cannot be equal to 2 raised to power x. Also, when y is 16, to the power of 2 raised to power x, that is, from here now, I have it that, let's put it right, that 2 raised to the power x cannot be equal to minus 12. Beautiful. Therefore, from y equal to 2 to the power of x, if y now is 16, I have taken this, that is this, but it cannot work for us, so I'm taking this. So y equal to 16 is 2 raised to the power x. Therefore, 16 can be written as 2 raised to the power 4, which is equal to 2 raised to the power x. The basis can now cancel, giving me x equal to 4. This works very perfectly. Therefore, we can now say that the value of x in the given equation is equal to 4. To authenticate our answer, we want to check result. Okay? That means from what I am given, the logarithm to base 4 of 2 raised to the power x, and the x now is 4. Okay, plus 48 is it equal to 4 minus 3 minus 1? Okay, that is x is now replaced to be 4. And that implies that I can have here the logarithm of 16 to base 4, okay, plus 48 equal to 3, that is 4 minus 1. But 16 plus 48 is 64. That means the log of 64 to the base 4 is it equal to 3. By same definition of logarithms, therefore 4 to the power of 3 should be equal to 64. 4 to the power of 3 is equal to 64 according to the definition of logarithms, that the log of a number to its own base is the power to which the base must be raised in order to obtain the number. Therefore, 4 raised to the power 3 should be equal to 64 by definition of logarithms. All right, beautiful. But 4 raised to the power 3 is 4 times 4 times 4, which is 64, equal to 64. Authenticating the value of x, that x is actually equal to 4. Thank you for watching this video to the end. I remain tutor Creative Sokoli. Also, like my videos and subscribe to my channel. Thank you for watching.